So the way I did that was I used a little trick that I know that I would like other people out there to know. If you're familiar with Corona at this point, and I think you probably are, then you've probably seen a timer perform with delay function call where you put in like 1,000 milliseconds and function and do it, something. You do some code in here and that's it. But what this is saying is wait 1 second and then call this closure. Closures are special functions. This dynamic function created at the time it was run, and inside that function, do whatever we did. So call do it, turret rotation equals 25. I'm just making stuff up as I go. Okay, just make this function as long as you want, and this is basically how you would wait 1 second to do a number of things, whatever those things may be. Now, the trick that I want you to know about is this is true of a lot of different features in Corona. But for example, if we wanted to, we could say turret timer self. I'm sorry, function self. This code right here. And then the old code so you can see it side by side. Here's the code that I just wrote where we called function do it and we set the rotation of turret to 25 and we waited 1 second to do it. Another way to write that same code is to write a function like this, store it in a variable called timer on turret. So basically turret now has a variable called timer that points to this function, and now we can say timer perform with delay 1000 turret. Pass in a reference to turret, and Corona is smart like this. It says, all right, that's not a function, so I'm going to assume that you just passed in a table or a object, display object, and I'm also going to assume that there's a field on there called timer, which is the function that you want me to execute. So now the reason why I like this instead of doing this is it's more self-contained. It's a little safer. Now, I don't know. In this case, it's not a big deal, but for like touches and collision events and all of that, anything where there is an event that has a name, you can create a field on an object or a table that has the name of that event and use it as a reference to a function, just like you would. It would have, the function itself would have the same signature as that collision, that listener that you would be writing. And it's a more compact, tighter way to do this coding, and it's a little bit safer in terms of like making sure it doesn't get called after the object has been destroyed and stuff like that. So let me get rid of all this code. I'm going to take us a little bit over our time because I just want to finish this discussion. So again, what we're doing is we've rotated our turret, and I want the turret to fire every so often. And I decided to do a timer, so I created a function, stored it in the reference timer, and the very first thing I do is, even though this is a very safe way to do things, I kind of like just to be sure. So the first thing, whenever I have like an enter frame or a timer and I got to manipulate an object, I verify that that object hasn't been removed in the interim. Because what can happen is if you defer an action using timer 1 second, and then 500 milliseconds later you delete that object, and then another 500 milliseconds the timer wakes up and you try to do something with it, you could crash your game. Why? Because you may try to call a function on the reference that is not there anymore. It's been removed. So a very simple way to determine if a display object is still valid, has not been destroyed, not removed, is check to see one of two different things. The most common one is just check for the existence of the remove self function. So if you say self, which is the object, that the reference that gets passed in here, remove self, if that is equal to nil, what that is saying is there's no longer a function called remove self. In other words, the object kind of still exists. There's a table out there, but it has been destroyed. It's been removed from the Corona display queue. It's no longer a valid display object. So if at this point you tried to say like self.x equals self.x plus 10, that would crash on Win94 because you're trying to reference self.x in a and then do some addition with it, which is completely illegal. That's like saying self.x equals nil plus 10, which is an illegal statement, which would crash your game. So again, this little tiny bit of code, which I usually just compact into a single line like this, simply says, hey, if you came in here and the object that I'm about to manipulate has been destroyed, just quit, exit, get out of here, don't do anything. Now there's a trick here. There's a little bug. I consider it a bug, whatever. If you've got a body on your display object and you come into a timer or enter frame, what can sometimes happen is the object has been removed, but the body still exists for one additional frame, which means that this first test here would pass. But if I said this, it would fail. So again, what's happened here is in the time since I set the timer, or if it was an enter frame, and since I set it and since we got to this point, the object got deleted, removed, destroyed. Corona thinks it's no longer a valid display object. But for whatever reason, for one frame, it can sometimes happen, the body is still around. So what you want to do is you want to check for the existence of set linear velocity, because this will definitely be set to nil once you've done a destroy or delete. So there'll be no way you can get in here and accidentally try to do some physics action on a body that was just deleted. So again, this is safety code. It's a little trick that I use to keep my code from crashing when I'm not 100% sure about the sequence. People told me that I'm doing things wrong, and yes, okay, right. The best way to do this, the safest way, is to cancel all timers, to cancel all enter frame listeners. But I'm kind of a lazy programmer in that I like to catch things just in time sometimes. And so this is my way of catching it just in time. It's the more complicated your display objects get, the more things you've got to track in your cleanup code, and it seems to me it always opens you up to that 99% of the time it works, and then 1% of the time after you released it, it didn't work, and if you'd just been safe, it would have been fine. So, using our timer, what we're going to do is we're going to create a display object, give it some color, give it a size, store it in the position of our turret. Then we're going to add a body, and we're going to use another filter, which I have set up in Common. If you remember in Common, I have set up the collision calculator so that I can simply set filters by saying give me or get the collision filter that goes with the name bullet. So I decided to use bullet as the object type or object name for lasers and rockets, so they all use the same one. And the rules for bullet are that bullets can hit platforms and bullets can hit the player, but everything else they pass through. I also set laser is sensor, so what I want is I don't want any collision response. I don't want it to bounce off of things or stop when it hits something. I just want it to keep going. But I still want to detect that there was a collision. So the is sensor flag is saying, yes, continue to detect the collision and throw the collision event, but don't respond. Don't bounce, don't stop, don't do any of those things when you hit something. Pretend like you can just keep moving. And then, because it's moving, generally anything that's moving and can be moving quickly, I use the is bullet flag, which is, it's a tip to the physics engine, which says, keep an eye on this thing and process it a little bit more because this thing is moving and it has a higher likelihood of hitting something. So you don't want to let it do what's called tunneling. Tunneling is when an object is moving, it has a physics body, and it's supposed to hit some other object, and instead it passes through. Tunneling. So to avoid tunneling, one way you can do this is simply set the flag is bullet to true, and you've decreased the likelihood that a fast-moving object will simply pass through another body without reacting or triggering a collision.